Welcome to our new series simply called Why. Hello, I'm Bob White with Cole Morgan, and today on Why, we'll find out why stepper motors sing. Someone applying a step motor for the first time may be a bit surprised that depending on how it is being driven, it will make sounds of various frequencies as it passes through its speed range. This is quite normal. Using a standard drive to run our step motor, we are basically pounding each coil with a square wave of voltage. Square waves bring with them a collection of harmonics that in turn excite the natural resonances of the laminated stator of the motor. As the frequency of the voltage square waves increases to drive the velocity higher, different resonances are triggered. The frequencies are quite predictable, which allows us to characterize certain velocities in musical terms, but we'll get back to that later. While we talk about step motors making noise as a natural phenomenon, it's not a trait that is always appreciated, and of course there are things we can do to quiet a step motor down. These include basic wave shaping, the voltages applied to the motor, to minimize the harmonic content and to reduce the forcing function of the current applied. Microstepping also helps reduce the noise. Now, while the typical sounds made by a stepper motors are just part of how they operate, we do realize there are unnatural sounds that should be listened for. Noise might come from faulty or worn machine parts, such as bearings, belts, or screws. Oh, and back to the music. We modeled a typical step motor's sounds and equated different speeds to each note on the musical scale, taking sheet music of a song and applying the duration of speed associated with the length of the note. We can play songs. So, join us next time on Why, when we talk about why step motors heat up quickly and run relatively hot.